This is the solution to WEX 310. Okay, find the natural domain of the following expression. Okay, so there's sort of two requirements. Because this is a fraction, the denominator is going to require that x can't be 6. Because you can't divide by 0. The numerator is going to require that x squared plus 3x minus 10 is greater than or equal to 0 in the end, because you can't divide by, you can't put negative inputs to the square root. Okay, so then in order for that to be true, in order to solve that inequality, well, first, the natural domain of just this inequality is all reals. So then we'll do the 0 and simplify step for that one. Well, one side is already 0, that's nice. And then simplifying it, well, I'll simplify it by factoring. So then that'll be x plus 5 multiplied by x minus 2 greater than or equal to 0. And then 3, I'll solve the corresponding equation. X plus 5 multiplied by x minus 2 equal to 0. So then that gives that x is negative 5 or x is 2. And then to make the sign chart, there's no fence posts because of the domain, but there's these two fence posts, one at negative 5 and the other at 2. So we'll pick points in each one of those. So negative 6, how about 1 and 3? So I'll plug those into each one of those. Each one of those right there. So that'll be negative and negative is the sign pattern in that region, and then positive and negative is the sign pattern in the middle region, and then positive and positive is the sign pattern in the right region. So then positive, negative, positive. And we want the positive regions. We want the positive regions because of that. So we also do want both boundaries because it says greater or equal, and there's no restrictions in the natural domain. So then that would be negative infinity to negative 5 union 2 to infinity. So that's what the denominator, the numerator requires. So denominator requires this, numerator requires this. So we need both requirements. So we need the numerator requirement and the denominator requirement, which is to say it has to satisfy this one but it also needs to satisfy that one, and 6 is in there, so we have to sort of puncture that one also. To see it visually, the denominator is saying I can deal with any point except 6, and the numerator well, we've got -5, and that's filled in, and 2, and that's filled in, 2. And the denominator is saying that it's able to deal with anything except 6. So altogether, that's saying that in order to satisfy both constraints, we need points that are both red and green. We want both, which is to say and, or if you like, intersection. Okay, so then the answer in the end, can be written in this way. So we want x less than or equal to -5. That's the left piece. Or we can be between 2 and 6. So or 2 less or equal x less than 6. Or we can be to the right of 6. In interval notation, that would be -infinity to -5, union 2 to 6, union 6 to infinity. Then, as an interval, it would look like this. So, up to and including -5, miss a little bit there, 2 including 2 to 6, not 6, and then onward.